Hi, this is Victor, and welcome back to my integral calculus tutorial videos. As I promised in the previous video, I'm gonna do another example for the area under the curve. And on this example, I would choose the function f of x is equal 1 plus 1/2 x squared. And I will study the area between 1 and 3. The previous one, it was between 0 and 3, and then y equal x2. You don't need to draw the image, but to understand, I will draw it for you. So this is 1, this is my summit, and I will study it between 1 and 3. So this is my 0, 1, 2, 3. So I have two parts here in the area under the curve. And this time I will divide it into n rectangle. And I will show you, if I set my n equal to infinity, the area under the curve will have the exact area. It's not an estimation anymore, because my lower bound, when I start with k equals 0 to n minus 1, here, n minus 1, will be equal exactly to when k equal to 1 to n, and when n goes to infinity. Yeah. So again, if I want to the width, because it is two-part here, the width between two rectangles sides, it's delta x, we call it, it's equal 3 minus 1, which is 2, because I have 1 and 2 here. But I want to divide it by n, because I have n rectangle, which is equal 2 over n. And if I want the height of this one, f of 1, so I have to add 1 first here, because there is a 1 that is here that I added here because I'm studying between 1 and 3, plus 1/2 x of 1 square. Yeah? So if I want x of k, it will be equal to 1, which is that 1, plus if I want k, okay, you will understand n over 2, yeah? But for the first one here, k can be equal from 0, 1, 2, till n minus 1, because those are my boundaries that I'm gonna set the lower boundary. It is for k equals 0 to n minus 1. So if k is equal to 0, I would start here. If k is equal to 1, so I will add to it n divided by 2. 1 plus n divided by 2. If k equal to 2, I will add this one and the one besides it. If k equal to 3, I will add the one besides it. So my x of k is 1 plus k times n divided by 2. So if I want the sum of all the rectangle under the curve, s of n will become the sum of f of x, which is, now if x of k is equal to this, f of x of k, it is equal 1 plus 1/2. Instead of putting x2 here, I will put the x of k, which is 1 plus k n over 2 square. Because this here is x square, but I replace x by x of k. So it is the height, which is f of x of k, times delta x, which is the width. So Sn equal the sum from k equals 0 to n minus 1. F of x is equal 1 plus 1/2, 1 plus k n over 2, actually 2 over n, sorry, 2 over n, because it is 2 over n here, k 2 over n square, time the delta x is 2 over n. So now I know that a plus b square, it is equal a square plus 2ab plus b square. That formula you studied it in previous years. I will use it to calculate this 1 plus k2, 2k divided by n square. It's better if I write 2k than k2, 2k, k2, because 2 times 3 is 3 times 2, so I can shift them around. So S of n equal sum k equals 0 to n minus 1. And I realize this 2 over n does not have k, so this will always be 2 over n. So whatever answer I will have here, I have to multiply it by 2 over n. So I can put the 2 over n outside my sum, and I will multiply it by the sum. So it becomes 1 plus 1 half 1. Okay, and here I will apply that formula. Once a is 1 and b is 2k over n. So 1 square is 1 plus 2 times 1 times b. 2 times 1 is 2 times 2k is 4k over n. Plus b2, which is 2k over n is b, become 4k2 over n. So now I will distribute the 1 half inside the parentheses. So S of n equal 2 over n sum k equals 0 to n minus 1, 1 plus 1 half plus 2k over n, because I divide this by 2, I multiply this by 1 and this by 2, plus 2k square over n square, because b square is 2k over n square. Now, if I look, I find that 1 plus 1 half are constant. I can add them together. So S of n equal 2 over n sum k equals 0 to n minus 1. 1 plus 1 half is 3 over 2 plus 2k over n plus 2k square over n square. Now I know that 2 over n I have to multiply it by the 3 term inside. So S of n, I will have 3 sum equal 2 over n sum of 3 over 2, where k equals 0 to n minus 1, plus 2 over n sum of k equals 0 to n minus 1 to 2k over n, plus 2 over n sum k equals 0 to n minus 1 of 2k square over n square. Yeah. For this one, I know there is no k in 3 over 2, so I can put it outside the sum, and I put 1 inside the sum. S of n equal 2 over n times 3 over 2 sum of 1. But let's say n is equal 10. So for k equals 0 to 10 to 9, because 10 minus 1 is 9, I have to add 1 10 times, because the first time 10 is equal 0, k is equal 0, k equal 1, k equal 2, till 9 it's 10 times. So instead of doing that, I will put k equal 1 to 10 to n. I'm allowed to do that because 3 over 2, or the 1 that is here, is a constant. So from 0 to n minus 1, it's exactly like from 1 to n. But it will help my calculation, that's why I did it. Plus 2, the 2 here and the n here are constant. It's only k that is not constant. So what I will do is I will put them outside my sum. So 2 times 2 is 4, n times n is n square, sum k equals 0 to n minus 1 of k. Here, because I have k here, the first one is 0. Like here, the first one is 1 if k is equal to 0 or if k is equal to 1. But here, the first one is 0. I cannot change the boundaries of my k. Plus, and again, the 2 would go outside, it become 4. The n2 would go outside, it become n3 because I have n here. sum of k square. Yeah? Here what I can do is 2 and 2, I can simplify it. So Sn is equal 3 over n. And sum of k equal 1 to n, if it is 1 to 10, it will become 10 times 1, which is 10. And here it's become n times 1, it become n here. So the n and the n would be simplified. Plus 4 over n2. And from my first video, I gave you the formula of the sigma formulas, and one of the formula is when sigma when the sum from 1 to n of k is equal. I will write it down for you, and I will delete it after. So if you Google it, the sigma formulas, k equal 1 to n, it's equal n times n plus 1 divided by 2. And I told you that n is at n here. But here I have n minus 1, so this will become n minus 1, and this become n minus 1 plus 1 divided by 2. I don't have a place, so I'm going to delete that formula. But if you Google the sigma, it's called, if you want to Google it, give you the right name to Google, sigma notation formulas. It's called the sigma notation formula. You will find it. So here it become and n, because it become n times n minus 1 divided by 2. Plus 4 over n3, and this is k equals 0 to n minus 1. And again, the formula would be, I will write it and delete it. For k equal 1 to n, it become n times n plus 1 times 2n plus 1 divided by 6. And you can Google it, and you can find it. But that n here is this n here, but me, I have n minus 1, so this become n minus 1, this become n, and this become 2n minus 1 plus 1 . So it become 2n minus 2 plus 1, it become 2n minus 1 this. So let me delete it. So it become here times n minus 1, or n minus 1 times n times 2n minus 1 divided by 6. Okay? So now, this is a lower bound, Sn equal 3, because n and n would leave, plus 4 over n2. And here I want to distribute this n inside. It become n2 minus n divided by 2. But here and here, this will become 2 here. Plus 4 over n3, and I will distribute first the n, which we did here. N times n minus 1 become n2 minus n, and I will multiply this by 2n minus 1 divided by 6. Now I will do the calculation of the two parentheses here. So Sn equal 3 plus 2n2 divided by n2 minus 2n divided by n2. Here I can simplify this and this and this and this. It become 2 over n plus 4 over n3 times n2 times 2n is 2n3 minus n2 minus 2n2 plus n divided by 6. So my Sn equal 3 plus 2 minus 2 over n plus 4 over n3. Here I have 2n3 divided by 6. It becomes n3 divided by 3 because I simplified. So this I got rid of is. This is okay. This is minus n2 minus n2 minus 3 n2 divided by 6 and plus n divided by 6. Now my Sn equal 5, 3 plus 2 is equal 5, minus 2 divided by n, plus, I will distribute this 4 times n3 divided by 3, 4, so it becomes 4 n3 divided by 3 n3, so it becomes 4 over 3, and I will distribute this with this. Plus times minus is minus. 12 divided by 6 is minus 2 divided by n, because n2 divided by n3 is divided by n. Plus 4 n divided by 6, it becomes 2 divided by 3 n2. Plus 2 divided by 3 n square. Now, Sn equal 5 plus 4 over 3, which is 3 times 5, 15, plus 4 is 19 over 3. So this is 19 over 3. This is minus 2n is minus 4n. Minus 4 over n, minus 2 over n, minus 2 over n is minus 4 over n. And plus 2 over 3 n square. So if I want to find the limit when n goes to infinity, so if n equal to 5, you replace n by 5 and you calculate this. If n equal to 6, you replace it by 6 and you calculate this. If n equal to infinity, of 19 over 3 minus 4 over n plus 2 over 3 n2, this will be equal to 0 because 2 divided by infinity is 0. This is 0. My answer would become 19 over 3. Now we calculated the lower bound. If I want to calculate the upper bound, instead of starting by 0 and ending by n minus 1, I will start by 1 and end with n. The area would become the Sn equal sum of k equal 1 to n of f of x delta x. But we know f of x is, we just calculated here, that's the f of x, 1 plus 1 half, 1 plus 1 half with x squared, but instead of x squared, I will put 1 plus, we said, nk divided by 2. Yeah, here, that's the mistake here. This is divided by n, 2k divided by n. No, it was not a mistake, sorry. Plus 2k divided by n squared, and my delta x is always 2 over n. If you follow the same logic and you do the calculation, you will have Sn, the upper bound, because I'm starting by 1, is equal to sum k equal 1 to n. And I will put 2 over n here. It becomes 1 plus 1 half, 1 plus 2k over n squared square, and you do the calculation. At the end, if you do follow the same logic, you will have S of n, the upper bound, is equal 19 over 3 plus 4 over n plus 2 over 3 n square. What we had before is minus 4 over n. Here it's plus 4 over n. But the limit when n goes to infinity, it's equal 19 over 3, because plus 0 or minus 0, it does not matter. This is 0 and this is 0, because when you divide by infinity, it's 0. So this way, we know exactly that the area under the curve is equal 19 over 3. Well, now we're doing it with the sum of triangle, but later on, I'm going to teach you how to do it with integral. If you like my video, please join my network, subscribe to my network. This will help me, and I will be able to help you to do more videos for you. Thanks.